let's look at this problem and kind of analyze our givens to decide where to go with it. So I have a mass of a compound. I also have a solution, and I need to get this mass of sodium hydroxide out of this solution. Remember that when you're given molarity, that is actually a conversion factor. It's the moles per 1 liter of solution, so keep that in mind. And then we also have a molar mass, which in chemistry, molar mass is always a possibility. So let's approach this as a conversion factor kind of problem. Because I don't know of an equation right off to use, and molarity is usually going to be that it's not stoichiometry. So let's approach it as a conversion factor problem. And the first thing to do is, well, what number do I start with? And I look for a number that's one number, 1 unit. And it looks like my starting number should be this 50. This is why it's important to understand that molarity is actually 2 units, because you won't start with molarity unless you happen to not have another number that's one number, 1 unit. But anyway, so I'm going to put grams down here because I want to get rid of grams. And so I've used this. And now what can I do? Well, I can't use the molarity yet to get to my volume, which is what's implied. But I can use molar mass to get to moles. And I have 40 grams. The 40 goes with the grams, so down here per 1 mole. And now my grams cancel. I have, my answer would be in moles at this point, but I don't want moles. I want how much would I use. I'm going to assume we're talking about how much of a solution to use. That's probably going to be a volume. So I want to get rid of moles and go to volume, which would be liters, and maybe you've already seen. Right here we'll use the molarity as a conversion factor. And so on molarity, I'll put the 0.20 down there and 1 there. And now I can see that my moles would cancel. And my calculator gives me this. But I see that my molarity only has 2 sig figs, so I'm going to round that to 2 sig figs.